everyone, this is our lesson on types of chemical reactions. So by the end of this lesson, you should be able to classify types of reactions such as synthesis, decomposition, single replacement, or double replacement. So first, let's go over types of reactions. So there are 5 general types that we'll look at. Synthesis or combination, so you might hear either one. Decomposition, single replacement, or displacement. Know it by replacement, but you'll hear me say displacement because that's how I was taught. Double replacement and combustion. So here's just an example of a chemical reaction. Actually, there's a couple going on in this GIF. So first, let's talk about synthesis. I try to use this in dating terms since you're in high school, and this is what I call the hookup. So a synthesis is where 2 or more substances react to form one substance. And this, we look for one product. Okay, so if you see an arrow and then only one thing after it, that's a synthesis reaction. Your general equation for this is A plus B yields AB. And here's just a quick example of what that looks like. So you could see on the right side of the arrow, we only have one thing. So that is a dead giveaway. You've got a synthesis reaction. So here is an example of a creation of a synthesis reaction, which is pretty cool. So now let's talk about decomposition, which is the opposite of synthesis. So I call this one the breakup. So this is where you're going to have only one reactant. So look for one thing on the left side of the arrow. If you only see one reactant, dead giveaway, it's decomposition. And it will break down into 2 or more simpler substances. And these are more difficult to predict. So you have to follow certain guidelines to know the products of a decomposition reaction. So the reactant must be a compound, and the products can be compounds or elements depending on how they break up. The general equation here, again, is the opposite of the synthesis. So it's AB yields A plus B. And then here's an example. This is one of my favorite decomposition reactions. So now, I didn't put this on a pop-up later, but you'll see it. So single replacement, this one I call the cheater. And this is where one element that is a reactant will take place of another element in a compound of the other reactant. So I like to say this is like a boy and a girl are dating, a new girl comes to that school, and the boy breaks up with the first girl and starts dating the new girl. So the single element replaces an element in the compound. So your basic formula here, sorry, there should be an arrow right here under the A and C. So AB plus C yields AC plus B. So you can see that C replaced B in the original compound. And here's an example of that. Oh, let me get that off there. Oops. So now double replacement is the switcheroo. So you've got elements within 2 compounds that switch places with each other. So it says here to exchange your cation, so you're going to flip the first element. So this will be AB plus CD yields CB plus AD. So as you can tell here, our outers go together and our inners go together. So you can see how we switched there. So an example is silver nitrate and sodium chloride form silver chloride and sodium nitrate. Another way to identify a double replacement is looking at what products form. So you'll always have one of these 3. A gas, so you'll see bubbles form and they'll release a gas. Water, which is the hardest one because you can't really see water being formed if you're dealing with 2 liquid, like two clear liquids, or a precipitate, which means a slightly soluble solid comes out of solution. So make sure you remember, and I'm going to write this here. So this is going to be two aqueous, which means dissolved in water, solutions. Ooh, that's sloppy. Sorry. Two aqueous solutions. So you have to have two, looks like liquids mixed together to make this happen. So again, remember, a precipitate is a solid that forms when two solutions are combined. And this is what a precipitate looks like. So we're mixing two liquids together, and when you do that, this solid forms and settles at the bottom. Sorry, guys, my nose is running. And then combustion is our last one. So I'll call this one the heat because it deals with fire. So this is where you have some sort of reactant, usually a hydrocarbon, which means based on the name, it's got hydrogens and carbons, reacting with oxygen. Oxygen has to be a reactant. Fire will not burn without oxygen. And then they will most likely produce water and carbon dioxide. So if you see oxygen as a reactant, water and carbon dioxide as your products, you are dealing with a combustion reaction. So here's an example. So you see we've got oxygen on the left, carbon dioxide, and water on the right. And there's a combustion reaction.